678-648-4277. You can mail us at support@mathhomeworksolver.com or reach us at https://www.mathhomeworksolver.com. For any help-related queries, call us at +1 678 648 4277. You can mail us at support@mathhomeworksolver.com or reach us at https://www.mathhomeworksolver.com. Problem 1. Find the following definite integral using integration by parts. Solution: let u equals x, dv equals sin x dx. The do equals dx, v equals minus cos ex. So udv equals uv minus v du, i.e. Problem 2. Find the following antiderivative using integration by parts. Solution: first substitute x equals sin theta, dx equals cos theta, d theta. Then the integral becomes, of course, sin theta, cos is theta, equals 1 to sin 2 theta. Thus we need to compute. mathhomeworksolver.com. Using trigonometric formulas, this equals, back substituting, sin theta equals x, gives the final answer. Problem 3. Use L'Hospital's rule to compute the following limits. Solution: a. As x approaches 0, both the numerator and denominator approach 0. The corresponding derivatives are, therefore, by L'Hospital's rule. mathhomeworksolver.com. b. As x approaches 1, the numerator approaches 4 minus 5 plus 1 equals 0, and the denominator approaches ln 1 equals 0. The corresponding derivatives are, therefore, by L'Hospital's rule. Problem 4. Determine whether the following improper integral converges or diverges. Hint: compare with another function. Solution: because the integrand is non-negative, the integral converges if and only if it is bounded. Therefore, the comparison test applies. For x greater than 1, x2x. Therefore, minus x2 minus x and 0 less than or equal to e minus x2 e minus x, integrating. Therefore, also dx converges, and is bounded above by e minus 1. mathhomeworksolver.com. Problem 5. You wish to design a trash can that consists of a base that is a disk of radius r, cylindrical walls of height h and radius r, and the top consists of a hemispherical dome of radius r. There is no disk between the top of the walls and the bottom of the dome. The dome rests on the top of the walls. The surface area of the can is a fixed constant A. What ratio of h to r will give the maximum volume for the can? You may use the fact that the surface area of a hemisphere of radius r is 2 pi r2, and the volume of a hemisphere is. Solution: the area of the base is pi r2. The area of the sides are 2 pi rh. The area of the dome is 2 pi r2. Therefore, we have the equation I equals pi r2 plus 2 pi rh plus 2 pi r2 equals pi r, 3r plus 2h. It follows that h equals the volume of the cylindrical portion of the can is the area of the base times the height, i.e., pi r2h. The area of the dome of the can is therefore the total volume of the can is. The endpoints for r equals 0 and r equals the critical points for r occur when mathhomeworksolver.com, i.e., a equals 5 pi r2. Since a equals 3 pi r2 plus 2 pi rh, we conclude that 2 pi rh equals a minus 3 pi r2 equals 2 pi r2. Cancelling, we have that h equals r. This is contained in the interval for r. Moreover, geometric reasoning, or the first derivative test, shows this is a maximum for v. Therefore, the maximum volume is obtained when h equals r. Problem 6. A point on the unit circle in the z-plane moves counterclockwise at a fixed rate of at the moment when the angle of the point is theta equals what is the rate of change of the distance from the particle to the axis? Solution: the coordinates of the point are cas theta sin theta. The distance from the axis is the absolute value of this coordinate. Since the point is in the first quadrant, this is just x equals cos theta. Therefore, the rate of change of the distance is. Problem 7. Compute the following integral using a trigonometric substitution. Don't forget to back substitute. MathHomeworkSolver.com. Hint: recall the half-angle formulas. Cos 2 theta equals 1/2 1 plus cos 2 theta sin 2 theta equals 1/2 1 minus cos 2 theta. Solution: this integral calls for a trigonometric substitution. X equals sin theta dx equals cos theta d theta. The integral becomes. By the half-angle formulas, this is. Using the double angle formula, sin 2 theta equals 2 sin theta cos a theta, and back substituting sin theta equals x yields. Problem 8. Compute the volume of the solid of revolution obtained by rotating about the z-axis 2 equals r for the region in the 1 st quadrant of the z-plane bounded by the axes and the curve x4 plus ry. Solution: the curve intersects the axis when r2 y2 equals r4, i.e. y equals r. The curve intersects the z-axis when x4 equals r4, i.e. x equals r. So the endpoints of the curve are 0, r, and r0. Using the disk method, the volume of the solid is. MathHomeworkSolver.com. Problem 9. Compute the area of the surface of revolution obtained by rotating about the axis pi the portion of the lemniscate r2 equals 2 cos 2 theta in the first quadrant, i.e., 0 less than or equal to theta less than or equal to. For solution, the polar equation for arc length is ds2 equals dr2 plus r2 d theta 2, which is equivalent to r2 ds2 equals r2 dr2 plus r4 d theta 2. By implicit differentiation, 2r dr equals minus 4a2 sin 2 theta d theta, r2 dr2 equals 4a4 sin 2 theta d theta 2. Therefore, r2 ds2 equals r2 dr2 plus r4 d theta 2 equals 4a4 sin 2 theta d theta 2 plus 4a cos 2 theta d theta 2 equals 4a4 d theta 2. The area of the surface of revolution is given by. MathHomeworkSolver.com. Therefore, the surface area is. Problem 10. Compute the area of the lune, that is the region in the first and third quadrants, contained inside the circle with polar equation r equals 2a cos theta, and outside the circle with polar equation r equals a. Solution: setting 2a cos theta equal to a, the points of intersection occur when 2 cos theta equals 1, i.e. theta equals pi/3 and theta equals plus pi/3. So the lune is the region between the two graphs for minus pi/3 less than or equal to theta less than or equal to pi/3. The outer curve is RO equals 2a cos theta, and the inner curve is re equals a. The formula for the area between two polar curves is. In this case, the area is. To evaluate this, use the half-angle formula, cos 2 theta equals 1/2 1 plus cos 2 theta. The integral becomes. MathHomeworkSolver.com. Therefore, the area is problem 11. Find the equation of every tangent line to the hyperbola C with equation y2 minus x2 equals 1, 1, that contains the point 0, 1/2. Solution by implicit differentiation. Therefore, the slope of the tangent line to C at x0, y0 is so the equation of the tangent line to C at x0, y0 is. If the tangent line contains the point 0, 1/2, then x0, y0 satisfies the equation. x0 equals square root 3 and x0 equals minus square root 3. The equations of the corresponding tangent lines are. MathHomeworkSolver.com. Problem 12. Compute each of the following integrals.